Good morning, everyone. Welcome to paper session 5 on machine learning and co-creativity. My name is Victor. I'll be the session chair. We have 5 papers. Each will be 15 or 10 minutes presentation with 5 minutes for questions and changeover. The first presentation is from Frederick Rodrigues from Deakin University in Melbourne on synthetic ornithology, machine learning, simulations, and hyperreal soundscapes. So we've got 15 minutes, and let's all welcome Frederick.
Hi everyone. So first, just to acknowledge we're on Ngunnawal country. It's colonised land where sovereignty was never ceded. My name is Fred Rodrigues, and I'm going to talk about this research project, synthetic ornithology, and I'm going to talk a little bit about how the work functions conceptually, a little bit of the technical aspects of the ML model we used in the research, and my approach to the installation and kind of experience design. So this is a short presentation. There's a lot more detail in the paper where I won't forget stuff and it will be a lot more accurate. So this is an installation, and basically it uses machine learning to generate birdsong from a future climate disaster. It's a work of speculative fiction expressed through audio, and the audio is soundscapes from future climate-focused scenarios from across Australia. And the center of the work is a machine learning model, EAGLE, so environmental audio generation for localized ecologies. And the entire sonic content of the work comes from a generative model. And this has a really big impact on, what you can do, the locus of artistic control as a sound artist, because there's all of the technical tasks of like model architecture, data set curation, annotating conditioning data, and training the model. They become the artistic inputs and how the sound gets shaped. And it really changes the temporality and the way that we work. And I, as someone who works with and many of us work with lots and lots of very technical things as part of our work, for me, I really imagine these as a new creative process. They are technical, but, as much as any of the other highly technical things that we use in making art. And so while the outcome of the work is audio, it is speculative fiction and it's interactive as well. It exists as an installation. And in that way, the user experience and interface design are really important. They become ways to change how the audience perceives the audio, how to frame it and present the work conceptually. So we're now in the kind of, machine learning and AI section of NIME. And historically as well, AI and ML have been used a lot in NIME projects, and many people have proposed different ways of how the tools sit within their creative projects. They get called autonomous instruments, collaborators, intelligent systems. I think particularly as these tools become more common or people get to play with them and experiment with them more, it's really interesting for everybody to propose how they sit inside their own practice. But they're technology, and I like to approach them in alignment with a group that I always really, really love, and that's the critical engineers. And they have a manifesto. There's QR code there if anybody's interested. And they say a lot of really cool things, but as a really terrible summary, technology should be dismantled, repurposed, understood, used, and misused. And that's an approach that I take when making my work, and I'm sure it's common to a lot of us. So that's how this work was made. And the outcome of that is that synthetic ornithology is parafictional. So it proposes that the speculative soundscapes generated by the model are an accurate representation of the future. And they might be. So if we wanted to generate soundscapes from a future climate disaster, how might we go about it? So let's have a look. We would maybe, this is the process that I went through, collect a data set of recordings that are annotated with the location, their times and dates, and as well as the climate data that they were recorded from that time and location, and get a lot of them. And then we could design a model that could learn the correlations between that climate and location data and the audio content. If the model and the data were good enough and the model architecture was appropriate, we could then ask the model to make predictions of audio based on inputting climate and location data. So it's a plausible approach. Anybody who's a specialist will probably tell me a lot of reasons why it wouldn't work, but this is a creative work. And this is a very important part of the work conceptually, is that the ML model is a plausible approach to doing this. And one of the cool things about that, for me anyway, is that it's sort of difficult to really understand if it would be accurate or not. So we're used to models of, questionable accuracy, and there are some things that are true here. So it is true that bird populations have been and will continue to be impacted by climate change, and there are documented changes in song patterns that have come from changes in climate, as well as the changes in song patterns that come from changes in habitat and food resources that accompany climate change. And it's also plausible that you could model the impact of climate change on birdsong with a machine learning model. So the whole project is taking this plausible, reasonable approach. And this is kind of important. So here we see weather. This is this week. On Saturday, it's going to be 22 degrees, right? Like, that would be nice. And it's a pretty cool prediction. I would like it to be like 22 degrees. It probably will be in Sydney, actually. Not in Canberra. But like, you can of course say there's no way that's going to happen. Historically, that would just never happen. But we can't really know for sure until after Saturday. So we can't really know if these predictive models work until the conditions they propose to predict have actually come to pass. And that is the kind of next bit of plausibility that I'm really, exploiting in this work. And that's how it kind of lets me bridge this sort of fiction and, proposedly accurate scientific approach of making this model to simulate the effects of climate change on birdsong. So in doing that, then the generative model that I want to use has some really particular requirements. It needs to be high quality audio, a reasonably long context window. So if any of you have worked with generative audio, sometimes they're only 4 seconds long, and there's lots of tricks to continue and lots of different things that people use. I need just straight up long audio. I want to be able to train on variable length training data, which is also can be difficult sometimes. Some models have big limitations on that. And I need to use supervised learning. Supervised learning, so there are lots of generative models. So Rave is a very popular one that's quite amazing and been used in lots of NIME research. Rave uses unsupervised learning. So it just kind of learns from data and learns features and arranges that data sort of autonomously. But supervised learning has conditioning data. It has that climate data and location data attached to every single audio sample. So instead of just learning about the audio data set, it learns about the audio data set in relation to the conditioning data. And it's that addition of conditioning data for me that is both really interesting because it gives another way of control over the generative output of the model, but it's also the mechanism that lets me kind of conceptually finish this work, because it's the mechanism that lets me input location and climate data into a model and get audio out of it. So this is the overview. So it's a latent diffusion model, which is a 2-part model. It uses the Descript audio codec as a sort of data compressor. I wonder if I can't really point here. Oh yeah, I can, cool. So we have some conditioning data that comes in. That's our climate and location data. And seconds start and seconds total are sort of remnants from the model that I was inspired and worked with to develop this. And I did mess that up. Start again. So the Descript audio codec sort of compresses the data first, and the diffusion transformer, instead of having to produce entire uncompressed audio, it just produces those sort of compressed tokens, and the diffusion transformer takes care of the conditioning data as well, and it uses self-attention, so it can keep that conditioning data across small sections of audio as they're added up, and it's a transformer, so it works on small sections in parallel. And it also has classifier-free guidance, which kind of lets you control how much influence that conditioning data actually has on the output of the model. You can sort of let it do more of its own thing. You can try to make it totally adhere to that conditioning data, which is a very useful thing for this kind of work. particularly when that structure and approach is really important, but I still want to have, be able to make it sound good, I guess. So here is the conditioning data that I ended up using. So the first two are these documented ones that you see, or first three. That is a location and timestamp. Now, those were required. Once you have a location and a timestamp, you can reverse look up the weather conditions to a reasonable degree of accuracy. And so I have these climate conditions and then minutes of the day, which gives us a kind of lets us know whether it's a dawn chorus, and it gives us that kind of diurnal variation, and day of year, which gives us a kind of representation of seasonality. And this was all of the audio samples only came from Australia as well, because otherwise this would get a little bit messed up. So spring is spring here and not spring in the Northern Hemisphere. And again, the second start and seconds total there just to kind of keep track of where those audio chunks came from in the original source file. The data set was taken mostly from Zeno Canto and the Macaulay Library with some agreements. There is about 44,500 samples, and they're all treated at 16-bit 441K. The audio data set is here. This is mapped and filterable by climate and location data, as well as the same seasonal and diurnal conditions. There's a QR code there. Outputs of the model. Anyone who is Australian might be familiar with some of these bird calls. So this is two quite famous birds that sort of morph between each other, some of the happy accidents that happen. So it is a pied currawong morphing backwards and forwards into a kookaburra. And I'll just play one others. I have like hundreds of hours of these. I really like them, but this is also just a really weird, nice one. Okay, and so after I made the model, I also did a survey to do what's called mean opinion score evaluation to kind of understand the fidelity of the model. This was done with people who are kind of professionals with audio and birds songs, so that's that pro level there, and also just kind of general public. And in general, people found it very hard to disseminate between the real and the generated audio. That is not what I wanted. Cool, next thing. All right, so we'll have a quick look at the installation and interaction design. So this is an interactive work where audiences get to choose their own future climate settings, climate conditions, and the installation will generate audio from there. And again, it is, the interface is built in JavaScript and the model is hosted on a Hugging Face space, so I can turn it on and off and I don't need to own an expensive GPU. And it let me develop the interface totally separately from needing to deal with the hardware for generating the audio. And again, it's sort of like, so there was a talk of Questacon the other day, which is like a science museum here. Basically, the whole style that I'm going for is Questacon. I want it to seem like it might belong in a kid's science museum. It proposes that it's accurate. So I don't use any cool, interesting interface. It's all just really standard stuff. It's a map. It's like those iOS roller wheels. There is something really weird happening with my video output, and it is all really basic. And then I also use ChatGPT to take the conditions that have been selected by the audience and create a sort of semi-plausible text that describes the difference between now and that chosen future with some series of events that might explain what happened and how the climate got to that state. And again, here is that style, like it's really, this is the installation in its kind of idealistic state. And it is really set up to be this sort of scientific style installation, but there are quite some cues and clues in there that sort of hint that it is also not real. Very quick note on resource use. I did use a lot of resources to train this. I was able to get a grant from the National Computation Institute, which is attached to this university, and it's a large research computational resource, and that is a lot of hours that I got. Now, the NCI are committed to zero emissions compute resources. They are a little unclear on how they achieve that. But it is great to know that they're committed to it. If I'd have done this on commercial resources, it would have been about equivalent to a one-way ticket from Sydney to London, which many of you might have done that equivalent to get here today for this conference. The installation is going to be, you can see it this afternoon and tomorrow, a kind of smaller compact version that I could bring here, and you can interact with it and listen to all of the weird bird sounds that are there. And in general, also, thanks to everybody who's been organising the conference and all the history of 9 people that have, submitted their work and published. It's an amazing resource to research and develop from and keep tearing things apart.
Great, thanks a lot, Fred. Does anyone have a question? I have a question. You talked a lot about plausibility. I'm wondering if you want to say any more about that, or also if you have any thoughts about kind of the difference between like a weather forecasting model, which includes like a causal model of the atmosphere, versus one of these probabilistic machine learning models, and like what's the status of causality and truth kind of in the work?
Look, I think like it is a really interesting question and topic, and I think like I would like to like just really briefly discuss that. Like the model, we use models in science all the time. We use models to describe how we think things might work, and those models are often revised, and that's innovation and scientific learning. So I'm particularly interested in that crossover between modeling and scientific models and ways of thinking about things and fiction, and that they are very, very similar. They also evolve. One of them, both can produce knowledge, and one of them is sort of locked tight about the way it's considered to produce knowledge. And I think like I'm an artist. I did some technical stuff, but I am sort of playing with a loose parallel of those things. The actual rigor and details involved in producing a weather modeling system versus the thing that I did, it's massive. I'm not claiming to have done that. I'm claiming to kind of play with something similar.
Sure. Yeah, thanks.
Yep.
Any other questions?
Hello. I think I'm going to go close. Thank you so much, Fred. If I'm a 5-year-old playing with this at Questacon, and I'm imagining, or playing with this and look at like, in my 30s, this is what birdsong is going to be like under these conditions. What do you hope that 5-year-old walks away from the experience with?
That's tough. I think it might be maybe ages 7 and up, but
that's avoiding it.
No. Yeah, look, I think it is. Although it proposes to the future, it's really about now. And and I think that's the thing, because it provides these sort of weird and degraded and sometimes strange soundscapes from a future. And they are, lots of the stuff in the archives that I've taken are like, handheld personal recordings. So they have this thing of like, presenting somebody walking through this imaginary future space and sending us back this recording of what it might sound like. And it is more about thinking about what we're doing to the climate now than it is about really proposing a devastating future. It is like a weird message in a bottle from a future that is a bit unclear of what it says. But to get that message in a bottle, like, if we get any kind of messages from the future that's, really interesting and valuable, like as you proposed in your keynote as well, that like, it is like when you start to talk from the future tense, you start to think about now. And I think it, that's really what it plays with. So, for the, 5-year-old who is playing with it, it's difficult. I don't know what a 5-year-old mind is like, but it is really about reflecting on where we might be going with everything that we're doing now, rather than really projecting what it might be like to be in the future.
I love it. Who am I throwing this to?
Do you want to say?
Yeah.
Good question.
Hello, fascinating talk. How do you isolate the core message of authenticity that the climate is changing from the artificial. So, for example, something building installation that shows how vaccines are killed. Same thing, but a false call message. How do you isolate the correct call message for your viewers?
Look, I think it's very difficult. I think, part of my approach is probably that I live in a bit of a bubble, that I don't know many climate change deniers, but I know a lot of people who, and myself included, who make, cursory steps towards things that we hope might make a difference. And it's always great to be reminded in every context, not just the news or, some inflammatory story, but I like to be reminded in an art gallery. I like to be reminded when I'm going to see a show of the realities of climate change. And I do think, I think my work has a limited audience. I don't think I'm going to do really well at communicating to somebody who's really dead set on, starting up a coal reactor, a coal burner to fire an aluminium smelter somewhere. But I think for your kind of centrist left person who is interested in art, they already have the view that climate change is destructive and that their own behaviours can contribute toward that maybe this is a reminder that makes them reevaluate some of those behaviours. So I don't think there is a way to isolate that and to produce some idea of, confirmed truth or opinion in some reliable way. But I think, and it will affect different people in different ways. But I do think it is relevant to an audience that I can reach, if that helps or answers.
Okay, I think we have to move on to the next talk, but definitely talk to Fred after the session. Let's all thank Fred again. And the next talk will be Sandy Ma from right here at ANU in Canberra with Touching Wires, Tactility, and a Quilted Musical Interface for Human-AI Musical Co-Creation. You've got 15 minutes, and let's all welcome Sandy.
Sorry, I couldn't figure out the HDMI mixer, and I got a bit shy. But thank you, Fred. That was amazing. It's a real thrill to be here presenting this project with the NIME community here on Ngunnawal Ngambri country. I've learnt so much. This is my 7th year here in Canberra, and this project really is a culmination of all my experiences, all my learnings in my time here. And I think First Nations knowledge is so important to a sustainable development of science and technology all around the world. And I am so grateful to be living and working on this country where we're afforded such an enriching relationship with our First Nations communities. I guess as a community of academics, artists, scientists, it's important to acknowledge the people who have contributed knowledge before us. So I'd like to pay my respects to the Ngunnawal and Ngambri people for their continuing care of this land that we're able to learn and share on this week. I'm here today to present Touching Wires, a project undertaken at the ANU SMAC Lab, the Sound, Music, Creative Computing Lab with Charles Martin. This is a quilted musical interface that has been presented as a gallery installation, a performance artifact, and the focus of this paper, a user study artifact. However, as many things are, as we're learning this week, this artifact is entangled with the experiences and motivations of all different sorts of people, of my practice, my experiences, and varying bodies of knowledge. This photo here, I love this photo because my arms look really good, is a photo taken at a gallery performance. It was a trio performance I did with my friend, performance artist Isabel Laxamana, who has travelled here from Gadigal, Sydney. It was a trio between me, Isabel, and our dear AI agent, Impsy Pie. And so I guess I'll start with a quick video to demo the work. The next slide has a video that's was the gallery installation where people could come in, touch the quilt, and create sounds in response to, or maybe with, or maybe a secret third option with MC Pie. tea. Oh, never mind. HDMIs. Anyway, you get the gist. Someone touches it, it's a call and response situation where if someone's interacting with the quilt, MCPI will listen. If no one is touching the quilt, MCPI will fill in the silence by generating predictions. And so the quilt is made up of 16 capacitive sensor arrays that's connected to the Trill Craft sensor. That's then connected to a Bella. If anyone in the room knows the people who make the Bellas, please forward my thanks. I was kind of skeptical when Charles asked me to do something not with an Arduino, but then the Bella really was that easy, so bless the Bella. But every technical presentation needs a system diagram, and this is mine. So as I mentioned, we've got this textile interface, capacitive readings that are fed into the Bella. The audiovisual output is built in pure data, P5, and that sort of is fed back to the human to complete the cybernetic loop. And on the other side, we've also got MCPI, which is a multi-density recurrent neural network model. I don't really know. You can read the paper. She was published in 2019. I'm just here for the textiles and the use of MCPI. Unfortunately, MCPI did not come with a set of training data built with a 1x16 array, so I had to actually have a few sessions where I was just playing around with my interface to build that data set to then train MC on. And so I like using my hands to touch things, so I'm usually a hand performer, gestural person, but I had to consider that other people might use other parts of their bodies. People might choose to roll around on it. I assumed because it was a blanket on the floor, people would be inclined to lie down on it, and I was right. These are some of my user study participants. The person on the right here was gone really crazy. I should have included some videos, but they were doing so much with their bodies. Meanwhile, the person on the left just decided to lie down on the blanket and sort of had this really beautiful meditative moment with the system, which I really, really loved. However, I should first probably talk about motivations. And so textiles is not an unfamiliar medium in this community. We've already had some really beautiful presentations related to textile knives this week. Joseph had a beautiful tuft and gun performance in the opening concert, which I loved. But I turned to textiles initially wanting to soften digital interactions. I was sort of caught up in wanting to make computers more comfortable to interact with and a bit more joyful and fun. I think as people with jobs, having a computer is often, I guess, a bit of, what's the word? A drag, I guess, something. It's a source of stress for me, but I need to have it everywhere with me. And so I thought making a musical blanket would be at least a fun way to interact with a computer. But I guess also to be very, very honest, and I feel like this is a safe space to be honest, I was also just really caught up by this meme of why did we make rocks think? If you're not familiar, stop programming computers. Sand was never meant to think. This is very cruel to rocks. And so in my mind, the antithesis to cold, hard rocks was warm, gentle textiles. And that led me to the whole e-textile thing. But as I dug deeper into this world of textiles, I found this really rich historical relationship between textiles and computation. We've got examples of the loom as sort of the first bits of analog computing. I also, in a contemporary setting, found this really interesting parallel between textile and technology supply chains. And in particular, I was responding to a workshop I attended at NIME last year about the lithium-ion batteries in vape waste. But both these supply chains are sort of plagued with issues of human rights abuses, overconsumption, and waste. And so I think interrogating this intersection of textiles and technology practices allows us to better engage with the humanity in our work. And so throughout this project, secondhand materials were sourced where possible, and the use of embedded computing systems enabled as lower energy consumption. And so the quilt on the left here was created with thrifted placemats that I suspect were homemade due to their unevenness. And the first prototype for this project that's on the right there is a tablecloth, and it was sort of really serendipitous. In both these shopping experiences, I was sort of ruminating what this interface would look like, and I had landed on having like a 5x5 square grid. And the next day when I was at Vinnie's, which is an Australian thrift store, this beautiful rose tablecloth appeared in front of me with the 4x4 square grid, and that was a really beautiful moment. And then when I was making the larger interface, I found 25 of these placemats in these really beautiful, gorgeous colours. So serendipity wins once again in an art practice. So this paper is centered around the results of a user study I ran late last year with 12 participants. Each participant was invited into this room where everything was set up, the sounds. They had a laptop screen where they could see the audio, the visual output, and they were instructed to create a musical interaction or performance with the AI agent. And I use the word AI agent, which I kind of wonder whether that influenced things, but more on that later. And they were told that they could interact with it any way they liked, with the caveat that there were wires attached underneath, so lifting it up was discouraged. And actually one of the participants was quite disappointed because they wanted to actually wrap themselves around in the blanket. And I was a bit sad that I wasn't able to give them that opportunity. They would also be given a verbal 8-minute warning. However, they could end the interaction at any stage before, at, or after the warning. And so we then completed a semi-structured interview that was then transcribed and then thematically analysed, as we do in HCI. So the first of these themes, which I think is, well, I personally find the most interesting, is that the expectations and biases that people came with into the interaction actually really dictated how they chose to interact with the system and sort of what they got out of it. And there were two main things that they were responding to. They were responding to the materiality and the visual imagery. So the checkerboard pattern, a lot of people made comments about it. There was this pattern. People were drumming it in the different sections as well. But more fascinatingly, the word AI kind of brought a lot of baggage with it. This participant said, I think any interaction I've had with AI at this point, I ask a question, it gives me an answer, or there's a reciprocity, but it's limited. And so I thought with this, if I touch it, it will give me an instant response, but it didn't. I just had to do my own thing and find my own rhythm and enjoy what I was doing. So they sort of gave up on trying to understand what the AI part of the system was, and just sort of had fun with the audio-visual experience they were afforded. And they weren't the only one. Many participants sort of commented on this sort of unequal sharing of a collaboration. I use the word co-create, I use the word collaborate. And when we were discussing this interaction, a lot of them were actually disappointed that there wasn't a sort of perceivable engagement from the AI agent. Yes. Oh, one more point. The materiality I thought was also interesting. One participant, like the second participant, sort of gave up on trying to understand what was going on. But on that journey, they started looking at the places in the quilt that had signs of wear to try and see. They explained it as trying to see what other participants had done to try and sort of fully understand what was happening. The other two I've lumped together because they sort of speak towards this combined experience of iterative learning. And I think exploratory learning is not a new concept, but I think it's often forgotten in the context of AI and emerging technologies. And so there were many different facets of the system for people to take in. There were lots of novel things, and they had to actually build up this relationship and build up their understanding of the system. And when we were talking about it, a lot of them sort of described it as they wanted more time, or they wanted a bit more information and autonomy into understanding the system, the sort of gauge of creating a musical interaction. In my interpretation of their words, box them in a bit. And while the participants didn't explicitly use the term embodiment, they used their body with the large interface and sort of describe this relational interaction between their actions and their sensory experiences. And so I guess in terms of evaluating what textiles brings to NIME, Sophie Skark et al. Put it best in their survey of the NIME archive that they published last year. They say, if nothing else, fabrics as instruments should prompt a playful, fun interaction. It's known that play is a powerful tool in learning, and I think it has great potential when trying to build and articulate relationships with emerging technologies. Through this project, we remind ourselves that our users are entangled beings. When we're designing interfaces for human-AI interaction, it is beneficial to consider how users perceive the structures of these experiences and their impact on the relationship between humans and machines. Everyone at the moment has an existing relationship with machines, if not computers, and so they bring all those experiences with them into these engagements. And I think in terms of overall, users want a really clearer defined role of AI in these engagements and sort of a better understanding of what the AI is actually engaging with. So I guess in terms of an ending, considering entanglement, embodiment, and materiality, I guess I hope that this project contributes to a better understanding of how human AI collaborations can be formed. Thank you.
All right, thanks a lot. Great talk. Does anyone have a question? Still work. Jump up to head this around. Thank you, super interesting talk. And I like the point you're making around the fact that people are told that this is AI, that they're kind of aware that this is AI, it's huge influence on what they do. What happens when you don't tell them? Would that be something to explore? Because you set these expectations. I'm curious about situations in which either you do something with an AI system, but you don't present it as such, or maybe more controversially, not using any kind of AI system whatsoever and telling people there's AI inside, just seeing what they say. How much of this is just prior my expectations?
Yeah, exactly. Same. I would love to explore more about it, and I guess in reflecting on this project, I, like in an ideal world, would love to do it all again without the word AI, just to see what happens. Maybe next year. Thank you.
Great talk. Some of the things you were talking about with the participants' needs, or they're not maybe wanting more instruction on things, and also the biases they brought in with them. There's a lot of that sort of stuff addressed in theatre participation theory. So there's an idea of perspective and change of agency. Ideas of imitation and how you communicate that to them. Did you have, how did you communicate in the gallery what they were supposed to do?
I need to dig back to October now. My brain. There was a room label that had the words AI and such, but I sort of, when folks came in, I just told them to touch the blanket and to see what happens. And then when people were like, oh, what? I would then sort of explain the technical side of it. I was also, while gallery sitting, writing my thesis, so I couldn't really take it all in. But I think people were just captured by the novelty of it all and the novelty of being able to actually interact with a blanket that made noise. And then on top of that, having this AI thing sort of hovering around it. Yeah.
Did they act differently when you did participant testing to in the gallery?
Not that I've noticed, there wasn't a stark difference. And I think I attribute that to just the novelty of it, and people trying to make sense of a textile interface situated in this AI cybernetic feedback loop. Yeah. Thank you.
Thanks again. I think we should move on to the next talk. The next talk will be Jason Smith from Northwestern University on adaptation and perceived creative autonomy in gesture-controlled interactive music. Please welcome Jason.
Hello, my name is Jason Smith. I am a researcher at Northwestern University, and I'm here talking about how a human musician might perceive and interact with an autonomous component of an interactive music system controlled by gesture. In interactive music, AI can be used to either create tools for musical expression, supporting the creativity of the musician, or an autonomous performer to collaborate with the musician, or to create something that blends the line between those two. The use of machine learning and AI could function as a tool or an actor respectively. And musicians might interpret whether or not the system's acting as a tool or an actor based on the creative autonomy, or the self-evaluation of the output independent of the user's decisions that the AI is making. Our goal with this research is to analyze AI-based music systems in terms of perceived creative autonomy, or how much the human user feels as if the AI component of the system is acting as a creatively autonomous actor rather than simply as a tool. So the research question of this project was, how can the ability of an interactive generative music system to adapt to a user demonstrate creative autonomy and increase the user's ratings for the system's anthropomorphism, how human-like it is, perceived intelligence and creativity of the AI component of the music system. And we also wanted to see how the user's ratings and perceptions change over time, or as the user gets more used to performing with the system. To answer these questions, I made a relatively simple interactive music system that uses computer vision and pose recognition using Google's Media Pipe to recognize and classify hand signs and gestures, so the shape of a user's hand and the motion across the screen, and then used adaptive machine learning behaviors in the form of online machine learning, or allowing somebody to retrain the model recognizing their gestures during the performance, or reinforcement learning to adapt the musical mappings that it makes during a performance based on the user's feedback. This work relies on some metrics or frameworks for how people might perceive the agent, such as creative autonomy, how independently is it evaluating the music, how well it supports the user's creativity, whether or not they feel like they're collaborating using the system or collaborating with the system as if it were an agent. Also, frameworks like mutual theory of mind. Do they feel like they have the same goal in a musical sense as the agent? And synchrony. Are they moving alongside it in a collaborative way? We also look at how tools can be treated like more autonomous musical agents. Are they purely reactive to the user, or are they performing more autonomously without the user's intervention? And in our study, we have users rating the system on a paradigm from tool to actor, or connecting that to instrument versus player paradigms. The two kinds of adaptive machine learning behaviors we use are online machine learning, adding new data, or reinforcement learning, structuring the agent's behavior based on some kind of reward signal. These have been used to create systems where training the system is part of the performance itself, like with Weckinator. And also reinforcement learning has been used as a way to explore latent spaces or explore different ways to control audio parameters by allowing the AI to take autonomous behavior and having the user be able to steer that system. The design of Gestalt which is named like after Gestalt, or the combination of different ideas in psychology, and also gesture, takes in a user's hand skeleton and then classifies that gesture to be used either in direct musical mappings or sending that gesture data to a reinforcement learning agent to automate or automatically apply these musical mappings. This is an example of the online machine learning with the system, where it by default has a series of gestures, the open, closed, pointer finger. There is no gesture for pinky, but by using a user interface prompt, adding a new key point label called pinky, so adding a new gesture, and then recording new data for that gesture while the system is running, it allows for somebody to add new gestures and thus add new musical mappings while using the system to control the musical output. So in this example, I record a few seconds of pinky gesture with both hands. And then after a short retraining window, the new gesture is added to the classifier. The online machine learning was added to our user interface for Gestalt so that the user could rewrite the label definitions to be mapped to different musical parameters during their initial time using Gestalt in a study. And our by default mappings without reinforcement learning were to the syncopation and rate of a deterministic melody. The second adaptive machine learning behavior was reinforcement learning, where the main hand is being used to control gestural recognition, and the second hand, my left hand in this image, is being used to give thumbs up or thumbs down, which change the mappings between gesture data and the sliders in this Max MSP patch, which is being sent through open sound control. So reinforcement learning in Gestalt is taking in all of the low-dimensional gesture data, the hand sign classification, its XY coordinates on the screen, and the motion, is it clockwise, counterclockwise rotation, or straight line, and alongside its choice of musical parameter, filter parameters in Max MSP, it's then using those and training a small neural network called Deep Tamer to maximize the likelihood of a predicted thumbs up with the alternative hand, changing the mappings between gesture and musical slider output or musical parameter control on the fly during a performance. More specifically, this application was written in Python for all of the computer vision and machine learning code, and then uses OSC, Open Sound Control, to send these points of data to control sliders in a max MSP patch that's controlling filter parameters. The media pipe hand detection to get simple linear coordinates of X and Y position, as well as the classification outputs, are sent to filter cutoff frequencies, resonances, as well as parameters to control the generated melody. To evaluate Gestalt, we performed a case study using a small number of people, but having them return 3 times a couple of weeks apart to see how they adapt to using the system and how they feel like it adapts to them as they develop a higher understanding of it between sessions. We started off by asking them their musical and computer science experience to see if they were able to have an informed conversation about their perception of the AI, and also what their experience playing with an AI might have been. Then, randomly, they either practiced and then performed recording themselves using the non-reinforcement learning version or the reinforcement learning version. And they watched videos of themselves performing, rating the system at various times as either a tool or an instrument and an agent, as well as did they feel like they were leading the system or the system was leading them creatively. Finally, they answered questions about the system's ability to support them creatively, their satisfaction in the visualizations as explanations, and their trust in the AI as a musical partner. Of our 5 participants, all of whom were Atlanta-based musicians, they all had a high degree of musical experience, a variety of main musical roles, but the full range of experience when it comes to knowing about computer science principles and having had firsthand experience playing with an AI. And to analyze the comments and feedback that they had, we looked at the quantitative ratings that they gave us, rather than trying to get statistical trends in the data. We used their ratings and how their ratings changed over time to see how the changes in mathematical ratings support the interviews that they gave us. And then we did thematic analysis to find commonalities between them. So some of the major themes we saw were that each musician brought in a preconceived notion of how they wanted to interact with the AI. And then, for example, the musically experienced participant B heavily expected instrument-like behavior, but the more computer science-minded E had a very specific notion of high performance for an AI. These preferences changed over time for some of the people as they changed their ratings and said, oh, I actually prefer the autonomous version now after it's done some surprising behaviors that they enjoyed. The impact of these adaptive behaviors was that the ability to add a gesture and customize the AI's behavior increased their reported understanding of how the AI component of the system worked, and also increased their ratings for the system's autonomy. And this was higher for the version that was using reinforcement learning, as they treated it more like another musician, using language like, oh, I'm playing a duet with it, or I trust it, rather than talking about the reliability of the online machine learning version, or the one with stable mappings. Also, any time that the system responded immediately to their feedback and surprised them, generally led to increases in terms of autonomy or system ratings. The musicians said that they would want to be surprised by the interaction with an AI. Lastly, their perceptions that changed over time included treating the visualizations as a distraction, but then relying on them as they learned things from the visualizations. So initially they saw many things as a negative that they then interpreted as a positive when they realized that they could learn how the system behaved based on it. And also, despite the system not actually containing a model of the user's behavior, their sense that the system did understand them increased over the time as they were able to communicate to it with their thumbs up and thumbs down at their second hand. So going back to the research question of how can adaptation affect their ratings for creativity and anthropomorphism, we saw that the users who use these adaptive behaviors increased their understanding, but their musical goals often were for the less autonomous version that they would want to be able to use their own creativity. And the output of this work or these findings led us to some considerations such as for building an AI-based or interactive generative music system, like supporting a user's understanding through visualizations that show the behavior that are specifically autonomous, encouraging surprise in an AI-based system, especially if that surprise is built on initially random exploratory reinforcement learning behaviors, and the ability for a user to communicate with the system or feel like they can communicate with it can change how co-creatively they treat the system. For future work, we want to look at longer periods of use or with more people. As one of the participants said, we're not going to become friends only after a total of 6 minutes of playing with it. And looking at more options for systems based in, instead of abstract gestures, musical input or more elaborate musical output like generative modeling. Thank you.
Yeah, thanks a lot. Great talk. Does anyone have a question?
Thank you very much. Great talk. My question, I think it's two-part. First question is, you mentioned systems like Wenqi. I also thought of lead motion, for example, and streaming OSC data map to some parameter, and then classifying hand gestures. My first question would be, to what extent is your system different than those two, for example? More different than, for example, Wenqi. The second one, to what extent, because you talked about autonomy, it is unclear to me to what extent like a classifier can be autonomous, and what is the creative autonomy of a system that just classifies categories.
Yeah, thank you. So the main idea behind evaluating the creative autonomy of a system that is a classifier, which is designed to 100% follow into it, is that we were looking at perceived creative autonomy, or what can a system do that affects the user's perception of that system's behavior. With Gestalt, the classification system itself, which would be on the left side of this graphic, which was taking in the actual classification of the user's hands and streaming that. The version that only did that with stable mappings, they rated very lowly in terms of autonomy. But there were still behaviors in which they were surprised by some aspect of the mappings that they had not learned yet, and the system felt more autonomous. In that sense, that autonomy went down as they learned more of the mappings and were able to find that behavior. I asked participants to rate what their ideal amount of autonomy would be. And depending on what that was, somebody who really wanted a system to behave autonomously worked on finding ways to do that even with a classifier by doing tricks or hacks, like trying to find ways to trick it to see what it would do, like switching the hands behind the head, using foreign objects like a pen to try to change things, or even like changing the positioning on the screen to be like, take my hand here, then take my other hand here, and try to move inhumanly fast between those to create new gestural inputs. This system itself, the big difference is the use of the reinforcement learning to alter those mappings based on the classification to translating to the music patch, but also the system's modular in the sense that the max patch is completely unrelated or completely created after the motion recognition system. So it could be created with different musical outputs. As long as the user is able to define through time spent giving feedback to the system, a new set of pairings between motion classification and the desired parameters.
It's very interesting. Just one thing about the first aspect of autonomy of the system, that the user found ways to be more creative. Do you think that amplifies the human agency than the system autonomy?
Yeah. I would say another big finding compared to the original subject study design was that any notion of creating a scale of instrument to autonomous agent revealed sort of the opposite of it is not a zero-sum game. A system can feel like an instrument while feeling like an agent. And a lot of participants, often exemplified that by trying to find behaviors where they could control one aspect, like, oh, I want to be able to control the bass with this and it's stable, but I also want it to be doing something wild at the same time. So they felt more agency in terms of, there were situations in which they felt more creatively controlled when they knew how to release the AI and let it do something more autonomous in the sense of it making its own mappings on the fly.
We can take one more question. Do you want to let the next presenter plug in while we do that?
Thank you. That's really interesting. I've got a probably politically incorrect question. I think from the paper you had 5 subjects aged from 24 to 70, is that right?
That's right.
So that's pretty much 3 generations. And so my politically incorrect question is, were there any behaviors that you could differentiate across the different age groups? Because obviously the rapid evolution of these systems is something you write and point out to in your abstract.
That's right. So because there were only 5 participants, I tried to avoid creating trends based on those demographics. But the oldest of the subjects also happened to be maybe the most 100% high musical experience, low computer science knowledge or experience, but had reported extremely high interest in using the AI. So for that participant, their journey of using the system started off as entirely testing the waters to see what could be done. They had a very high preconceived notion of the AI acting like an instrument that followed their conducting. But after that, they started to appreciate or learn more about these kind of autonomous behaviors. And they had very markedly changed their ideals of what their ideal rating would be. Saying, at first they thought, oh, I would want a system to totally follow me. And then at the end they said, actually, the system doing its own thing is good sometimes. Thank you.
All right, we should move on to the next talk. Let's all thank Jason again. Our next talk is from Wenqi WU and Hanyu QU from the Hong Kong University of Science and Technology, and it's on gesture-driven DDSP synthesis for digitizing the Chinese Erhu. And this will be a 10-minute talk. I'll give you 5 and 2-minute warnings.
Okay, so thank you. I'm Wenqi. I'm now an MPhil student in the Hong Kong University of Science and Technology, CMA. And I finished this project with my colleague Hanyu from his support of the cultural background of Chinese heritage. I'm very happy to introduce my project, gesture-driven DDSP synthesizer for digitizing Chinese Erhu and NIME at the first time. I know many people are already familiar with the DDSP. It's famous for its differentiability techniques. For it can be used as a white box and be used in a neural network. You can use the backpropagate to optimize it and to train end-to-end generation models that can generate this timbre in the real time. And I always think DDSP have a very big potentiality for some instrument developing for example, you can write it in some development board. Then people use DDSP to duplicate many classical instrument sound like violin, flute, voice, or something. And this project, I extended to Erhu, a traditional Chinese instrument. Erhu is a two-string Chinese bow instrument known as very expressive and voice-like sound. It got two strings and one bow between the strings. We use our left hand moving on the vertical direction to find the position of the pitch, and use my right hand when it's moving on the horizontal direction. The velocity is to map with the volume of this instrument. And Erhu is very expressive instrument. It can be known as some kind of Chinese violin or something. And I also think the scale of Erhu, the player playing Erhu, is very intuitive because you can use a video by camera to capture all of the 80% of the message about how you control the feature of a song, like the pitch, how you control the pitch and how you control the loudness. The system overview is have three steps. The first one, I record my own dataset of Erhu for about 1 hour's improvisation, and I train my DDSP models, about 30,000 training steps. And the third one, I finished all of the interactive mapping in Max environment. For some maybe don't know what the Erhu sound like, I shows my videos when I'm recording this dataset. You can take a listen. Okay, so as you see, I record with 2 Max, and the whole data set is, the length of that is about 1 hour. I train for 5 checkpoints to test the trade-off, and I finally find the 30,000 training steps can be the best trade-off between the stability and the quality. And after I train it, I send it to the Max environment with open sound control. And I tried 2 methods to capture my hand pose. The media pipe is hardware free, but it got a lower accuracy and higher latency, so I finally mainly used the lead motion to capture my hand pose. And this picture is how we calculate every parameters with the raw data. I just calculate the distance between my thumb fingers to each 4 fingers and some spatial rotation angles of my 2 hands, and just like what is shown in the picture. And after I do some calculations, I send its parameters to the features of a sound, like the pitch. I inspired by the original Erhu player's scale, so I also used the left hand direction, moving on the vertical direction to map that to the pitch, and use my the velocity of my right hand moving on the horizontal direction to move that to the amplitude. I also set a quantized pitch mode, which means I can pick the note from a fixed, discrete scale, but it still have the glissando, which means you can control the parameters to control the one note from one node to another node, how many times going to spend. It's around the range between 0 to 500 milliseconds. And I also add some filters to make the data transmission stable. And after I finish the foundation of that, I add some pinch gestures, some techniques to make the whole system performance more expressive. When my index finger touch with my thumb fingers, the whole pitch going to move about 1 semitone. It just imitate a real player when they play the Erhu as a trill. And when my middle finger touch with my thumb finger, it's going to move about 1 whole tone. And here is the final interface I designed in my Max environment. After I finish that, I'm trying to put it with different kind of music characters and performance that in different kind of scenarios. This video is what I performed in electronic music club. It's about 100 audience under the stage. So, as you see, I think compared to some traditional rule-based data mapping, the DDSP output response is more expressive and human-feeling timbre, and I use my left hand not only to control the Erhu pitch, but to control some other electronic tracks to trigger the drum and the bass lines, and you also use my right hand to trigger some drums, use the rotation angles of my two hands to control some granular effectors, and I use my thumb fingers touch with my other four fingers to randomly trigger some nodes on our ARP, synth, pads, and plugs. So, come to the conclusions. I think this project could be seen as a new example for how to digitize a traditional cultural instruments. And this time I digitized Erhu, but you can digitize for some more beautiful instruments. And DDSP always show a very big potentiality for instrument design. And I think maybe next time you can design some more fancy interface to get your body language as the input and use DDSP as the output, and the sound could be more expressive and more interesting. And as what I said, I think Erhu's playing skills can be seen as a very good pair data between how people performance and how the sounds output. And in this way, maybe the Erhu playing performance videos can be seen as a natural pair data to be trained as end-to-end generation models. You can use your Erhu playing videos as the input and some other sounds as the output, and use the gestures control to be seen as some how you manipulate the pitch and how you control the amplitude to ask the neural network to find the regulation of the timbre changing. So that's my presentation. Thank you for listening.
Wonderful and great timing. Does anyone have a question?
I thought it just made something a little different. But you go from the two and I wonder why that is, whether your natural Erhu trained gestures are perfect for using a therapy, or whether the wonderful audio that you've matched is just perfect for those gestures that anybody can use. It's a wonderful thing.
Yes. It's very similar to theremin, but maybe you use your right hand, the velocity of changing the amplitude, not like the theremin is what I'm playing, but it's very similar.
I just wanted to ask about the music that you gave the DDSP model when you were playing the Erhu, and if you tried different ways of playing, such as playing scales and more even perhaps examples, or if you're playing music, what kind of audio did you give it?
Sorry, can you ask?
The audio of yourself that was put into the DDSP model?
Yes. Oh, yeah. It's a sine wave. It's a sine wave table. Is what I've done is this max environment. I can see it in this picture. Is here the phasor. It's not a sine wave. Sorry, it's a phasor.
Oh no! In back when you were training the DDSP model, did you do that?
Yeah, I trained that, and
you had you said 30,000 steps was a good amount.
Yeah.
The audio that you were giving to that point.
Yes.
what kind of music did you play?
Just like what I shown in the videos, and the data set is just like what I'm showing in these videos. I record the Erhu playing as my original data set and train it as the DDSP model. Then in the max, the input of the audio is from the phaser oscillator. Then the output is the real Erhu timbre, not real Erhu timbre, but the Erhu timbre.
I'd wondered because the DDSP model, it works a little bit like a vocoder in a vocoder in a lot of ways. And I'd wondered if maybe more, even playing, giving it exact scales or things like that, versus playing expressive music, if that was something you tried. I don't know which is better myself.
Yes, I think everyone has his preference. I actually don't know how to say what kind of performance better between the DDSP or some other methods, but I just like my project and how it performs.
I like it very much too.
Question down here.
Hey, thanks. That was really beautiful. I have two really quick questions. Because you played the instrument and you were playing the DDSP version, how accurate do you find the pitch? Like, do you feel like you're using the same gestures as you would when you're playing the instrument as to when you play the DDSP version?
Yeah. Yes. First, I think the DDSP maybe have some difference. It used to creepy to cognize the pitch of that, but actually I don't feel the real difference between I play the DDSP and I playing the real instrument. But I feel it's kind of hard to find a pitch with the lip motion because it's still not very accurate. So that is why I set the one test pitch mode to make this more friendly.
And just on that, because you said you were using MediaPipe and the lip motion, were you using them together? That you use MediaPipe to get a XY position of your hand in general, and then using lip motion to get finger positions based on that?
Yes.
Or did you just use lip motion alone?
I tried MediaPipe, and it's just like what I'm using the lip motion. I also use the MediaPipe to capture the spatial message of all of the things, but what I find is it's not very accurate. It's not enough to be performed.
We can take one more question while the next presenter plugs in. Could you let the next presenter plug in?
It's just a short question. When you talk about DDSP, I saw at least 2 times in the slides that you were talking about DDSP being more expressive or more natural. So I should like for you to unpack a little bit what do you mean by that? And in comparison to what do you think is more expressive and more natural?
Yes, of course, that's my own perspective, but I think DDSP is wide expressive because when you're changing the pitch and the loudness from a continuous input, the timbre is changing in the real time. Actually, the DDSP is how DDSP works. It's changing the harmonic waves, the position of that in the real time to calculate that. And I think because it has some mapping between the harmonic distribution and pitch, but use neural networks to calculate that, and maybe can make it more expressive because the Erhu, when I played Erhu at this position or at this position, the timbre is totally different. But use DDSP can all of the document that and to play it in the real time. You need to rule base to set up all of the rules of that, but DDSP already set the rules for you. So that is what I think that is expressive. I don't know if the already.
Yeah, when you say setting the rules for what?
Setting the rules for how it's changing the timbre.
Okay, what system do you have to do that?
For example, to change some, to use some filters, format filters, or some other pitch centroid filters to control, or some physical modeling, some steps.
Okay, thank you.
All right, great. Let's all thank Wenqi again. And the final talk is another 10-minute talk. It will be from Lucía Montesínos from the IT University in Copenhagen. So take it away.
Hello everyone, my name is Lucía Montesínos and I'll be presenting my paper called Enabling Embodied Music Making for Non-Musicians. So the project is rooted in the concept of musicking, which I imagine many of you are familiar with, but basically comes to say that music should be an action, so then therefore the to music should be an active process for anyone involved in the experience. So kind of with that concept in mind, we carried research through design exploration of tangible interactions to enable active music experiences. This whole project is inspired by the rush experience during a performance when being in the flow and wanting others to experience that. And then the question that we came up with was, how can we support non-musicians to have an embodied and aesthetic experience through music making? We looked at previous work in the field, and then we decided to come up with 3 design principles to guide our exploration. Firstly, we thought that the system overall needs to help non-musicians to create something that sounds good to them without them requiring any initial skills. Secondly, we wanted that the interaction elicited a sense of agency and ownership of the sounds generated. And finally, the overall goal of the interaction is that participants end up with a meaningful music experience. So after several iterations, we landed on this, which we call Tubularium. And it's what we call a musicking artifact, a tangible interface with features tailored to support active and embodied music making. And it was designed with an intentional ambiguity in order to encourage a diversity of approaches for touching and playing. It consists of 7 acrylic pipes, and each pipe or tube is a note in a heptatonic scale, and then we have 3 octaves. And here I have kind of annotated a bit of like the different parts. The kind of black box thing over there is a controller that basically allows to navigate through the different features. And among the features, we can change the sound, the scale, the key. We have a history-keeping mechanism, being able to record and play. And then we have what we call AI jamming, which is a hidden Markov model. But yeah, I'm just going to show you a quick video of how this sounds like. I'm getting the MacBook, the little, oops.
Have you set your system sound to?
Yes, yeah, but I think it's kind of crashing. Let's try again. Okay, kind of sucks because it was a 1 minute demo. But yeah, basically what I was showing was the AI feature. To use it, basically you record a line and then you hit the record button, and then you click on the AI button, and then it basically plays back infinitely kind of all the combinations of what you've played before. And the idea is that you can then explore the sounds with play on top of that kind of recording, and then play with the rest of the features to keep playing with your own sound. What we did was an evaluation, and the goal was to see if participants had an aesthetic experience in this music making kind of process. We carried a self-assessment of their music skills, and then participants were invited to interact with the artifact freely for as long as they wanted. And then once they felt like they had enough, we conducted a short semi-structured interview. And then after a month, we contacted the participants again for a follow-up interview because we were interested into the sense-making process that they had over the experience that they had a month ago and to see how much they could recall of it. And yeah, we had 32 participants. They interacted with the artifact both individually but also in groups. And then most of the participants were novices, but we also have a bit of different levels of skills. Here I have another video of one of the participants. I'm gonna try. Let's hope this one works. Yeah, I don't think it'll work. Well, maybe you can find me later if you're curious to see how it sounds. But yeah, I'll then just jump into the evaluation results. Okay, now I'm getting again the little fault. Cannot really move on. Yes. So when overall the participants from all skills level indicated that the system was intuitive, and that was kind of a key factor for them to feel like they were doing something that sounded good or sounded interesting. For example, one of the participants said that they liked that they were able to record and then play back, and also that they were kind of for the first time making something that they enjoyed listening to. We also saw that participants were making sounds that sounded like music that they know, so it made them want to try and jam. Also, we observed how participants build a mental model based on their previous experiences with other musical instruments. So, for example, a novice participant enjoyed the playfulness of discovering slowly what was happening after touching the different things. And then a participant who self-assessed as competent said that, they needed a bit of time to kind of figure out the possibilities, but then he could get going pretty quickly. Something interesting that we observed is that not all the participants explored the kind of AI feature, but those who did, most of them were novices. And we think that this perhaps reflects that they had more need for creativity support than those who were more skilled users. As for the kind of immersiveness, a lot of the participants recalled feeling immersed and forget everything that was around them. Some got into a zone, got captivated by it, and this was also reflected in the follow-up interview. And some participants even felt inspired to go and make music, which was really great to hear. So our findings is that the design of the artifact inspired participants to use their bodies in different ways, and these uncover a set of patterns. So, for example, those who were gently caressing the tubes, making stretchy notes, dreamy sounds, recalled having a meditative experience, whereas those who were kind of hitting the tubes in short and rhythmic kind of patterns, and they said that it reminded them of their clubbing experience. We also identified 7 patterns in hand movements. So these are kind of represented by the arrows. And participants were not only using their hands or fingers, they were also using their arms, and also some of them were using their faces. Also when with the participants who participated in groups, we saw that the relationship in between the members was also manifested in the way that they were interacting with the artifact. So, for example, the couples were interacting in a more kind of intimate way, kind of intertwining their arms and making the artifact somewhat part of the relationship, whereas the friend groups were more like playful overall. And yeah, we also observed that there were different motivations in the interaction, and that kind of resulted into different explorative strategies. So most of the novices performed some kind of horizontal exploration, trying all the different features, whereas the most proficient or competent participants did more of a vertical exploration, in which they found one sound that they consider interesting, and then went into, kind of go full into it. And yeah, just to conclude, the broad diversity of ways that the participants engage their bodies to interact with the artifact does offer and encourage validation of this design approach. And overall, we think that this is a promising direction for future work in designing this type of artifacts for non-musicians. Thank you very much.
Great. Do you want to try playing your video outside of the slides or anything? While people formulate their questions?
We can give it a try. Just don't know why it crashed.
Maybe if you have it and this outside of the slideshow.
Yeah, I'll find it and put it up there.
We're a little bit short on time, Victor, so maybe we can and we're actually over time. I'm waiting for another session, so maybe we could take one question.
All right, does anyone have a question?
Someone's holding it.
Hello? Thanks. This is very weird. In terms of the form factor, of the music and artifact, do you think that for beginners, particularly, do you think that form factor facilitated the playing of the instrument, or the exploration of music in general?
Yeah, well, thanks for your question. I think what we wanted to explore with the shape was that it was inviting to play it in different ways, and that there was not a right way of playing it. So I think in that sense, we tried different materials and different shapes, and we figured that by leaving the right amount of space, you could approach it with your fingers, with your hands or your arms. And I think it was familiar enough, but also novel enough to don't come with preconceived ways of how it would be played.
Thanks.
Okay, I think according to Charles, we've got to move on. I think there's another session beginning imminently. So let's all thank all the presenters again.
Taking the mic off, Victor. Thanks, folks. Very tangled. Okay, we have a bit of an extra session during the lunch break, which is a Fairlight CMI demonstration and chat from one of our staff, Professor Samantha Bennett at the School of Music. So if you'd like to have a look at the CMI working example, newly refreshed, go to the School of Music, the big building, not the little one we were at last time. You go up the lift, and you go into the studio, and you go in there, and you can see the Fairlight. So please, a few of you, go and look at the Fairlight. I think they're waiting in the studio for some folks to come. So it'd be great to have a look. Thanks.